Hi, welcome back to my channel. If you're new here, please consider subscribing. In this video, I'll show you how we can prove that sec power 4 theta minus cosec theta is equal to sine squared minus cos squared theta over cos power 4 theta sine power 4 theta. So this is kind of an easy problem. So to get started, we just need to know what is sec. Again, if you remember, this is the same as 1 over cos of theta. And what is cosec? Cosec theta is the same as 1 over sine of theta. So to do that, we are just going to substitute in on the left hand side directly, and then we see that sec of power 4 theta minus cosec of power 4 theta is the same as 1 over cos power 4 theta, then take off 1 over sine power 4 theta. So we have this, and then the remaining part is to have a uniform denominator, right? And so this is going to give us cos power 4 theta sine power 4 theta, and then if we try to rearrange this, put everything on the same denominator, this is going to be this by that, this goes, and then we remain with sine power 4 of theta minus this divided by that, sine will go, and then we have cos power 4 of theta. So when we get here, we need to use some of the ideas we know, expressing this numerator in terms of difference of two squares. So in order to do that, we are going to first rewrite power 4 in terms of squared of theta, then this is squared, then minus cos squared of theta squared, everything over cos power 4 theta sine power 4 theta. Note that the denominator is already what we need, so we are good there. So the next part is just to play around with the numerator. And so this is the difference of two squares, and if you recall that, you have a squared minus b squared is going to be equal to a minus b, and then this is into a plus b. Okay, so when you have this, then you can make use of it down here in the expression. And so that's going to be sine squared of theta minus cos squared of theta, then into sine squared of theta plus cos squared of theta, and the whole thing is over sine power 4 theta, and then cos power 4 theta. Right? So again, I'll remind you that we have the fundamental equation, which says that sine squared theta plus cos squared theta is equal to 1. So observe that in the numerator we have this part, this bracket, which can go to 1, and so I can then rewrite that as the balance is sine squared of theta minus cos of squared theta, then times 1 over cos power 4 theta sine power 4 theta, which is exactly what we wanted to prove. So it's easy. It's always the idea is always to know what you want to prove, how you get there, and then what kind of substitutions you are going to make.